Hey everybody, this week we're going to talk about parts of speech tagging, NLU, and we'll talk about collocation. I think I'm saying that right. Collocation. So let's jump right into it. So for this one, we'll talk about parts of speech, but let's go over what we'll talk about more in depth. So for this section, we'll talk about a couple different things, right? We'll touch upon the POS taggings. We'll talk about why it's important within NLP. Then we'll explore more about the NLUs that we talked about a couple weeks ago, such as roles and semantics and kind of context awareness. So it's a super important part of it. Um, and then we'll jump into collocations, so and their types and how they enhance NLP systems by improving just the flow and generating responses. So let's jump right into it by talking about the introduction of parts of speech tagging. So with the POS tagging, in this process of labeling each word in a sentence with its parts of speech, quote unquote, such as a noun, verb, adjective, this task is a fundamental to many NLP applications, from machine translation to semantic analysis. So the POS tagging helps the system understand the grammatical structures of each sentence. The semantics of each sentence structures. For instance, identifying which words are a verb helps the bot understand what action the user is trying to take or trying to ask about. While recognizing nouns gives the bot an idea of what the user is talking about, without the POS tagging, it would be much harder for the NLP systems to process language at a very semantic level. So now let's talk about it. Let's talk about it in why it's most widely used standard. So known as the Penn Treebank Tagset. This tagset was developed as a part of the Penn Treebank project, a large annotation of English language that provides just the different ways that the words and sentences can be structured, and the parts of speech annotations for various numbers of sentences. It is essentially for a couple different reasons. So, what is this? What is the Penn Treebank tag set? So this is a standard within the sets of POS tagging that assigns a specific label to each word in a sentence, depending on its role. It's also one of the most commonly used tag sets in NLP because it provides a comprehensive range of parts of speech and grammatical notes. So for example, some of the most common tags include NN for nouns, which is singular, VB, which is for verb, base form, JJ for adjectives, and RB for adverbs. So each of these tags is crucial because they help the system break down the structure of a sentence. The tag set is much more extensive. However, it includes over 30 different tag sets to represent various grammatical structures. So why is standardization so important, and why do we even care about it? So, like, why does it matter, right? So standardizing ensures transparency across different NLP systems. Whether you're working on a chatbot, like how we are, a search engine, or a machine translation tool, using a common POS tag set allows different models and systems to speak the same language. This makes it easier to integrate different tools, compare performances, and maintain compatibility when expanding your project to different areas. So for instance, if your system tags the word jump as a verb using the VB tag, it will be understood by other systems using the same tag set. This standardization becomes particularly crucial when working for large corpus like the Penn Treebank corpus, which has been tagging accordingly to this set of standards and has become the benchmark in the NLP research area. So how do you deal with ambiguity and just variance in general, right? So this tag set addresses some of the more nuances and ambiguity of the English language. It has helped tag different verb forms like VBD for past tense and VBG for present particular tense. In this way, it allows the system to be more refined tuned and helps make a decision based on how the phrase is perceived and parsed and understood. So another example is, so consider the word running. Is it a noun, as running is my favorite hobby? Or is it a verb, as I am running to the store? This tag set differentiates these forms as NN for the noun and VBG for the verb form. This is crucial to helping NLP systems debunk ambiguity words and help make more semantic interpretation based on the context itself. Nice. So let's jump over to the next one. So when evaluating the performance of a parts of speech tagging or POS, I'll kind of stick with saying POS, makes it a little easier, tagging systems. It's important to use a robust metrics and how are we going to accurately and identify areas for improvements. So let's explore some main evaluation metrics for POS tagging. So we want to make sure it's accurate, right? So the most straightforward metric for evaluating POS POS tagging is accuracy. Accuracy measures the percentage of words in a sentence or a data set that is correctly tagged with their respective parts of speech. For instance, if 90 out of the 100 words in the sentence are tagged correctly, your accuracy is 90. Pretty straightforward. However, accuracy alone doesn't tell the full story. While given a good overall performance metric, it doesn't capture the types of mistakes the system is making or how severe those mistakes can be. This is where other metrics like confusion matrix comes in. So now we jump into confusion matrix. So a confusion matrix provides a more detailed breakdown of the system's performance. It shows how often the system confuses one part of speech for another. So for an example, the system might mistakenly tag a noun as a verb or vice versa. These errors are placed in a metrics form where rows represents the actual POS tags, and columns represents the predictive tag. Each cell in the matrix shows how many times a particular tag was predicted instead of the correct one. The matrix is particularly useful for understanding the nature of errors. For instance, the system might confuse verbs and nouns more often than confusing nouns to adjectives. This insight can help you focus on improving specific areas of the tagging model, especially when there are certain tags that are frequently misclassified. So what are some common tag errors? So when we work with POS tagging, some of the most common areas include verb to noun confusion, adjective to adverb confusion. And these areas, so we go back to verb to noun confusion, right? Let's think about this. How does this particularly happen? So this happens when a word can be both a noun and a verb. So as we talked about before, such as run, and I run every morning. Run in this case is considered a verb, but I went for a run is a noun. This kind of mistakes are especially common in languages such as English, where many words can function as multiple parts of speech depending on the context. And then we jump back to adjectives to adverbs. In this confusion, another frequent confusion that we have here is, for an example, he runs fast. The word fast is an adverb, modified the verb run. But she is fast is the same word as an adjective describing the subject. If the system doesn't account for context properly, it may mislabel these. So improving these systems with this performance of making sure that we have different metrics such as the accuracy, confusion matrix, this just helps us get a better error, right? And for this, to improve the performance of the POS tagging system, it requires a careful error analysis. By breaking down the types of mistakes with a common matrix, you can adjust the system to be better to better handle ambiguity and help handle ambiguity cases. So it improves overall accuracy. It's just a better way to do it. You got to track what you're doing or it's going to run wild. So next, let's jump into the hidden Markov model, or the HMMS, in POS tagging. So this is widely used as part of the POS tagging because of its ability to handle sequential data, where the identity of each part of the sequence, in this case, each word's parts of speech, depends on the surrounding words. So let's break it down how HMM works and why it's so powerful within the POS tagging. So first, let's actually just go into talking about what is HMM. So an HMM is a type of predictive model that predicts sequence based on hidden states. So remember that. So it's a model that predicts sequence based on hidden states. In the context of the POS system, these hidden states are the parts of speech tags. The goal of the HMM is to determine the most likely sequence of the POS tags for a given sentence. So the Markov assumption behind the HMM simplifies the problem by stating that the probability of a word's parts of speech depends only on the parts of speech of the previous word. So, in other words, what this really means is that the parts of speech of the word you're tagging is based on the assumption that the previous tag influences it the most. So how does this work within the POS tagging, right? How does this all make sense? So for this one, we want to understand how the process thinks in these two decisions, right? So we think about transition probability. So this is the probability of moving from one POS tag to another. For an example, given that the current word is tagged as a determinator, DT, the next word is most likely going to be a noun, N, than a verb, VB. This model calculates the likelihood of the translationing from one tag, transitioning, there you go, that's the word, transitioning from one tag to another based on the trained data. And then the next is the omission probability. This is the likelihood that the particular word appears given a specific POS tag. So for example, if a word is tagged as a verb, VB, the model calculates how likely it is for the word run to appear in the position. The system combats both of the transition probability, how likely a tag is to follow another, and the omissions probability of how likely a specific word is given in a particular tag to predict the most probable sequence of POS tagging for a sentence. So how is this effective, right? So we understand that the strength of the HMM lies in its ability to consider the context surrounding each word, rather than to tag each word is isolated. By factoring the most probable translation from one word, by factoring in the most probable transition from one tag to the next, HMMs excel at capturing the grammatical structure of a sentence. They can resolve ambiguity where a word can serve more than one part of speech, as we talked about previously, based on the probability of what comes before and after. For an example, the phrase "the dog runs." HMM will recognize that the determinator DT, it's highly probable that the next word is a noun, dog, right? Based on this, it can correctly tag runs as a verb using the transition probability learned from the trained data. Now let's jump into what we talk about the conditional random field, or the CRFs, an advanced probability model that is used within the POS tagging. Well, the HMMs are effective for tagging words based on adjunct tags. CRFs offer a more flexible and accurate approach by considering the entire sequence of the words, rather than just focusing on one transition at a time. So what is CRF in this situation, right? So a conditional random field, or a CRF, is a type of discriminative model that used for labeling sequences, like a sentence of a word. Unlike HMM, which relies on a strict transition probability between adjunct tags, CRF can then take into account of long-range dependencies in a sentence, meaning that you can incorporate context from multiple parts of the sentence to provide more accurate responses. In this most simplest term, where HMM might only consider the relationship between a word and its immediate neighbor, so the word right next to it, a CRF looks at the entire sentence at once. This is crucial because the most correct That's because the correct part of a part of speech for a word often depends on the larger context, not just the word before and after. So POS tagging within the CRF. So we understand the CRFs are especially effective at handling sentences where a word's part of speech depends on a long range of dependencies. So for an example here, the word bank could be a noun, which is considered a financial institution, or a verb, to bank on something. Depending on the sentence, with the CRF, the model doesn't just rely on the word immediately before and after, but instead it considers the entire context of the sentence to make the correct prediction. CRFs are particularly useful in a situation where contextual information from the entire sentence is crucial for making an accurate prediction. So they are also a discriminative model, meaning that they directly model the condition probability of a tag sequence given a sentence. Unlike HMM, which models joint probabilities of a sentence and a tag sequence. So let's jump into section 2 now, understanding natural language understanding, or NLUs. So we've already talked about POS tagging, how important they are. So now we want to dive more into how these systems understand each other. And to do that, let's jump from POS tagging to NLUs. So we previously understand that the POS tagging, where it helps to identify structures of a sentence and how words are organized, but understanding language at this level only gets us so far. To build intelligent systems, we have to move from syntax to semantics, which is understanding what the word means and how they can work together to form the meaning. So this is where NLU comes in. NLU is a process of analyzing and understanding both of the syntax and semantics. While POS tagging is the first step to break down a sentence, the NLU takes us a little further by helping the systems understand what is being said, why it's being said, and how to respond accordingly. It's crucial for tasks like analysis, answering, question answering, and context-based dialogue systems. So again, what is semantics? What is syntax versus semantics? So first, we talk about syntax, which refers to the structure of a sentence, and how the words are arranged to form a meaning. So in other words, the grammar that dictates how words should be ordered. So for example, within the English language, a type of sentence structure follows a subject, verb, object as VO order, like the cat chased the mouse. Syntax tell us that the cat is the subject, chased is the verb, and the mouse is the object. While the POS system helps us understand the structure as well, it gives us information about the role of each word. So whether it's a noun, verb, adjective, and adverb, as we discussed way before. And semantics is another kind of goes beyond this structure, which it's about the meaning of an individual word and how the word it's combined to convey an overall message. While syntax answers how the sentence is structured, semantics answers what. What is the sentence meaning here? So for an example, the cat chased the mouse. Semantics tells us that the cat refers to a specific animal, chased refers to an action, and the mouse refers to an object being pursued. Semantics involves understanding words, meanings, relationship between words, and conceptual information. So again, POS tagging within all of this is crucial because it helps us breaks it down, adds the attributes to them, and helps us understand what this all means. It helps us understand what it means too, but furthermore, it helps the systems understand it much better because we understand English as a structured word, and we can talk in slang and informal text that the systems, if it's not taught appropriately, it's not going to know. So next, let's jump into the word sense disambiguation in NLUs. So a specific challenge within the NLU is dealing with the words that have multiple meanings. So the WSD refers to the process of identifying which meaning of a word is intended for a particular context. So for many words in English and the other languages, these things are ambiguous, meaning that they can serve in multiple functions and have different meanings depending on how they're being used. So let's take an example here. So the example here is the word book. So the book can either be a noun or a verb. In English, so in read a book and book, so in the sentence, read a book. Book is a noun and refers to a subject you can read. Now, in the sentence, book a flight, book is a verb meaning to make a reservation. So without understanding the context in which book is used, it's impossible to determine its correct meaning. This is where POS tagging helps initially. It labels the book as a noun or a verb based on the role in the sentence. So then we think about, how does the POS tagging help us in this first sense of kind of disbanding ambiguity? So the word in tagging correctly, go backtrack. Once a word is tagged correctly, the system can use the surrounding context clues, like other words in a sentence, to infer the correct meaning. For instance, in the sentence book a flight, the system recognizes that flight is a noun related to travel, and the book in this context means to reserve. On the other hand, in this sentence, read a book, the system knows that book is something you can read based on the verb read that comes before it. So what is so important about the WSD? So with this one, it's so crucial for building systems that truly understand languages. Without it, systems that might respond incorrectly because it'll interpret it wrong because of the sense of a word. For an example, if you ask, how can I book a table? The system needs to understand that the word book means to reserve, not read, like read a book. Effective WSD allows systems to avoid these types of confusions and provide more accurate responses for you. So what is some context awareness within NLUs? So it's to fully understand human language, context awareness is crucial. And NLU, so within this, NLU is super important. Words and sentences don't exist in isolation. They are parts of a bordered conversation that means it can change depending on the context in which they appear. So think about a conversation you have with people. If someone says yes, you probably know that they're agreeing because you follow the conversation. But if you only hear yes without any prior context, it's kind of difficult to understand what they mean. The same applies to NLP systems. So to interpret users' input correctly, systems need to look beyond singular sentences or words and understand the conversation as a whole. For an example, imagine the chatbot asks, would you like to order pizza? The user responds yes, and the chatbot needs to understand that yes refers to the ordering the pizza, not a random question. The border conversation helps determine the meaning of a response, and this is where context awareness becomes very crucial. Pragmatics and NLU, the study of how context influences meaning and called pragmatics, and is crucial part of NLU. Pragmatic deals with understanding how language is used in specific contexts. So for an example, if someone says, can you open the window? They are likely making a request, not asking whether you are physically capable of opening the window. Pragmatics helps NLP systems go beyond literal meanings and understand intent. In NLP systems, pragmatic reasoning involves using context, whether it's a broader conversation, user history, or external factors, to make decisions about meaning. For example, if a user is chatting with a bot about flight bookings and later says cancel it, the bot understands, it needs to understand to infer that the user is asking about the flight booking, even if flight isn't mentioned explicitly. So, well, let's go into an example of this, right? So, a good example of context awareness is seen in a dialogue system and chatbots. So, for instance, if a user asks, "What's the weather?" and follows up with, "How about tomorrow?" the system needs to understand that tomorrow refers to tomorrow's weather. It can't answer the second question in isolation. Similarly, in question answering systems, if a user asks multiple questions in a row about a same topic, the system must recognize that the common thread between the questions and the main context throughout the conversation. So with that being said, context awareness ensures that NLP systems can maintain the flow of conversations, which is super important. making interactions more natural and meaningful rather than robotic. Without it, systems can send a fragment or disjointed manner, leading to confusion for users. This is why incorporating these different systems is crucial into your NLP systems. Lastly, we'll talk about kind of from syntax to NLP applications within the chatbot, right? So we understand a whole bunch of reasoning, and I want to kind of go over about pragmatic responses adapting to based on conversation. So one of the key applications within NLP systems, or within NLU, is chatbot's ability to produce pragmatic responses based on what we just talked about before, meaning that the bot can adapt its responses based on the context of a conversation. Unlike simpler chatbots that respond to each messages individually, NLU-powered chatbots track the conversation as a whole, which allows them to understand how users' input fits into the broader dialogue. So within your projects, you're going to be doing a system that is very simple, that you'll ask a question and it'll have a predefined response. But later on, when we get more advanced into the chatbot, you'll be able to have that chatbot kind of think on its own and remember the conversation prior. So for an example, we'll talk about, would you like to book a table? And that's what the chatbot asks. And you respond, yes, please. The chatbot has to naturally understand that the yes refers to booking the table. And this is the form of the context awareness and pragmatic that is essential for smoothing the natural conversation. Because if you just said, yes, please, and it's going to ask you, what do you mean? Well, that's not continuing the conversation, right? So that's why these two things are super important. I also want to kind of bring it all together. So when we think about why the semantics to NLU allows chatbots to go beyond, it's to understand the structure, right? This entire lecture has been revolving around the idea that these systems need to understand context. And to do that, they have to break down the words. They have to understand the meanings of the words. They have to understand where it's coming from. Is a verb or is an adverb? These are all the things that go into just a simple version of understanding what you're asking. So to us, it may seem simple. We're asking a few questions, it responds. It's, when you think about like ChatGPT, but there's so much in the back end that is super important that we have to consider and that we have to understand. Most systems that you'll work on will probably have this done already. So this isn't something that you have to super rely on understanding, but it's super important to understand that these are all the elements that go into building what we need to build. So for section 3, we'll get into the introduction of collocation and their importance within NLP. So what is collocation and why is it important within NLP? Collocations are words that are frequently appear together in a language. They help us understand not only individual words, but also natural relationship between those words where they are used in real life conversations or writing. Like, what is collocation, right? So collocation essentially is word pairing or grouping that occurs most commonly in English. They aren't random combinations. They reflect the pattern of usage that people naturally say and adapt to. So for an example, we say make a decision, not do a decision. Unlike saying, likewise, we say fast food, not quick food. This common combination of words sounds natural to a natural speaker, if you're an English speaker, and understanding these patterns is crucial to NLP systems and generate a human-like response. We don't like robotic response. So there are two different types of collocations. There's lexical collocation and then there's grammatical collocation. So let's go back to the former. So lexical collocation, this involves a combination of two contact words, so such as a verb, noun, adverb, adjective. So for instance, as we said before, make a decision or take a break, or examples of lexical collocations where the verb and the noun commonly appear next to each other. So grammatical collocation, this involves the contact words being paired with grammatical words like a preposition. A good example is depend on, where the verb depend is always followed by the preposition on. Grammatical collocation helps NLP systems understand structure rules. And so again, all of this being said, why does it matter? Collocation is essential for making language sound more fluent and natural. When we use words together that don't typically appear in combinations, the result sounds pretty strange and robotic. For instance, do a decision or powerful T might seem grammatically correct, but they sound kind of awkward because they violate the common collocation pattern. So for NLP systems, recognizing and generating correct collocations is key to producing a natural sounding response. We just skip one. So how does it enhance switching how is it enhancing the language flow? So collocation plays a crucial role in ensuring that the language flows more naturally in both speech and generative text and text generation. So where the systems can identify most common words pairing, they can produce more human-like languages. So for an example, the NLP systems can understand the word strong tea is a natural word to describe tea, rather than saying it's a powerful tea, which is grammatically correct, but this just sounds weird. Um, this can help generate more appropriate and fluent responses. So incorporating collocation, it helps prevent the kind of awkwardness, robotic responses that make a system make a system feel more artificial. By relying on common pairing, chatbot and voice assistants can interact with users more naturally, making the experience more intuitive and friendly. If you have a Google at home, or if you have all these Alexa, definitely start talking to it. If it sounds very robotic and starts talking like that, that's how you know it's not working as efficiently. So it helps with this. When you think about the n-gram, so this is the part where it can predict the next word based on the context of the word prior, or maybe the context of the sentence. It just helps make things flow much better. So if you ever have any text messages with your iMessage, you'll see where you'll be typing, and sometimes it'll kind of give you like, I think this is what you're gonna say next. And in that way, it helps kind of just make life a little bit easier, but also it has learned from your text messaging style on what to do. So from there on, we think about some of the improvements as well, right? So, oh, sorry, let me go back. So training the models, right? So to train this, we need to have large amount of data. That's just simple as that for it to understand the language of an individual. So the more you give data to the system, the better it'll recognize patterns and adapt to it. But NLP systems, and we think about some improvements, right? So recognizing a collocation makes NLPs much better because it generates language much more efficiently. Since real-world language depends on heavily on common words pairing, incorporating collocation into the training of a model leads to more fluent and more context awareness response. By capturing frequent words pairing during training, models can better reflect how human use language, ensuring that the generated text or chatbot responses don't really feel unnatural and robotic-like. So in the whole summary of it all, we understand that whether if you're using a simple model that like the n-grams, or a more advanced system like the transmitters, understanding that collocation is a key to improving the naturalness and the coherence of a language generated by the systems itself. So with that being said, thank you for joining, and I'll see you next week.